Another device which makes use of electrical field and magnetic field, a cyclotron. So the basic idea over here is that it is going to increase the speed of a charged particle. It's going to accelerate it. So the obvious question is, what is the point of that? What is the use of that? Well, this particle which has a lot of energy in it, this is made to hit atomic nuclei and study that. So you already studied in chemistry and previously physics also, and you'll be studying again about how we happen to and how we understand nuclei, right? Study of that. So this is also used in radioactive substance in hospitals for treatment and stuff. So the usage is pretty good. You can see a real life set of things over here which just works on the simple concept that we have learned. Of course, the devices are not a lot more concept, but fundamental principles are this. So this is how it looks. So we're looking at the structure. So basically, we have to have a source of what? Electrical field and magnetic field. So your magnetic field is produced by what? Magnet. So generally, this is the north pole of the magnet. This is known as D1 and D2. We'll understand the usage. We have a source of magnetic field that we got it. Obviously, this too has to be source of correct electrical field. This is alternating voltage. Now let's look at the job of a magnet over here. See, let me go to the funda. Let me ask you guys this. Say we have an object and we want it to accelerate as much as possible, right? I'll give you guys two scenarios. Same amount of force, starting same object, starting from u is equal to 0, u is equal to 0. If I happen to apply same amount of force, say 10 Newton, but the time available for this is say 10 second and say for this is 15 second, which will gain more acceleration? Obviously, the second one. We are pushing it for a longer time. So here I'm able to pushing it for longer time. And so more acceleration. Now, what if I don't have this much of space? How else can I do it? If there is a space issue, a space constraint, what can I do? Think of it. So this is the basic idea of cyclotron. I know I can push charges, right? All I have to do is take a plate, take another plate. Say I want to push an electron. I keep an electron over here. I switch on the battery, making this as positive, negative, and it moves, right? But why should we do all of this? End of it, magnetic field will not produce any push. It just makes it go round and round. How can I push this for a longer time given there is a constraint of space? And when we have such a thing, why should we have this setup? What I can do here is I can go or make something go round and round, make it gain acceleration. That's what they do when they're throwing the, what do I put it across? Disc, right? Olympic and all of the athletic stuff. So disc and heavy stuff. Sorry, I'm not able to put across actual names, but yeah, you got the funda. What do? They basically hold it, make it go round and round, and yeah, they have the advantage, right? What did they do? To gain that velocity, to gain that acceleration, to give that acceleration, they make it go round and round. Of course, they do it for one round, but think of it. If I can go round and round as much as possible, as many times as possible, what can I do? I can get a lot of space. Is it not? The length is what is important. So this length into n number of times. This is basically 2 pi r into n. So within the space of, within this space, right, basically r square or a bit more than r square, I'm able to get infinite length. So this leads to longer distance, right? By making something go circular and then allowing it to give an opportunity to gain velocity, get accelerated. So that's the role of a magnet, to make it go or make it take a circular path. But why do we need a circular path? To increase the path. Increase the distance, not path. Let me put it as distance. So when we have this opportunity of having infinite distance, how can I make use of it? Well, that's where the job of your alternative voltage and D1 and D2 comes into picture. Alternating voltage is over here, D1 and D2 is over here. So you can see that there's some space. These are, you can think of them as empty space. Okay, these two. And they are not connected. They have a bit of distance. The question is, what's the point of that? Well, this is what it is. Let's go back to the original idea. I have a positive charge. I have a negative charge plate. I have an electron, right? What will happen if I keep it over here? It will rush to the right. It will get accelerated to the, not right, sorry, left. An electron, that is. That's good. Say we know that it will go circular. It will take a circular path because of the magnet. But again, when it comes out, what happens? It will go a bit forward and come back, is it not? Why is that? The reason being, you have the positive charge, so positive will pull and the negative will push. What if I'm able to make this plate flip the orientation at the right time so that this set will be negative and this will be positive? What will happen to this electron? It will rush. If I keep doing that, what will happen? The velocity of the particle will increase. As simple as that. So basically, we need something that can switch between these two plates, make it positive ones and make this positive ones. So keep alternating. And that's why we have alternating voltage. And D1 and D2 gives that opportunity to do that. Basically, they will push and pull. One will throw, another will catch. More than that, I think push and pull will be a better word. One will push, another will pull. Pull. This being positive and this being negative at this moment of time. This guy will push, say D1 will push and D2 will pull. When it comes over here again, that time what happens? Then this will become negative, D2 will become negative and D1 will become positive. So D2 will push and D1 will pull. And this keeps happening and the particle will gain the required velocity. So electrical field is produced in this space. Okay. This is a space wherein the particle increases its speed. So this is the entire funda, as simple as that. Very simple concept, right? So yes, this is the introduction. We'll get the mathematical expression in the next video. For now, please copy everything. And by the way, once you get to accelerate that, this is the point of exit. You should not be doing this.